Hello and welcome to Slack Chats Season 2. This is episode 9. I'm Stuart Winter, the platform architect and developer of the ARM port of Slackware, and we've got Phil, who maintains and develops SARPy, which helps you get Slackware running on Raspberry Pis. And we've also got Brent, who's back with us again. So hi guys.
Hello.
Hi Stuart.
How are you guys doing?
Very well. How's it going with the Slackware building?
It's been quite intense. There was a lot to do because of the world rebuild for the glibc 2.33 update. And that took about a week and a half of building on ARM, and then about another 3 days just to build KDE. All in all, it took about 2 weeks to do a world rebuild on ARM, but I kept it up on the ramps for a while longer because Patrick's developing at really quite a rapid rate at the moment. So that it's better just to take a lot of the packages in and consume them. I tend to just put roll-up update batches out these days, and that tends to work quite well. So also, because I had the whole port up on the ramps for a while, that made the AArch64 port a lot easier because I was able to go and edit the build scripts easily and just throw them back in the rebuild queue for ARM. Because what I've been doing is where I'm making changes for AArch64, I've also rebuilt the package on 32-bit ARM v7 as well, just to make sure that that still builds a package properly. So I've called those consistency rebuilds. So that's a lot easier to do when the 32-bit port is up on the ramps, and I'm not pushing it out. It allows me to make changes far more easily. So I've been doing a lot. I've got all of the world rebuild done. I've got AArch64, the base OS built, and I've rebuilt it I think twice now. So it's not fully baked by any means, but I've rebuilt it I think 2 or 3 times, and so it still requires several rebuilds to get everything working and everything linked together that should be. So you can have a look on the website and you can see the machine itself. Once I finally got it self-hosted, and I ran the native script setup that you've seen in some of the previous podcasts. The thing automatically wired itself into the build system, and the build information appeared on the website automatically, which I was quite surprised about. I thought I had to manually go and do it, but I guess I figured that was too much work and automated it from the ground up. So that was quite a nice surprise. But that just goes to show that I've kind of found the amount of detail I've been working on has made me forget the larger picture sometimes. There's a lot of different moving parts. Brent's also been helping out because Brent's got himself a Rock Pro 64, haven't you?
Yep, I love it.
It's a nice machine, isn't it?
Yeah, I was surprised for the price compared to other units out there.
Yes, yeah, it's really cheap for what it is. And honestly, if someone had given me one of these a few years ago, I would have done an AArch64 port earlier because it actually is a joy to use. I mean, ARM is fine, but to build packages and things like that, it's a little bit slow, even with a cross compiler. Going around the system and using it's fine, but because I build packages for the most time, it's.
What do you call cheap, Stuart?
$80 for the 4 gigabyte.
$80 for the 4 gigabyte, you say?
$80.
Yep.
That's not bad actually, considering the system on chip that you get. I'm not surprised to hear that it's fast, but $80 is a really good price, especially when you compare it with other systems like the Vim 3, which is $130. It's quite a price difference.
And they have a lot of places to connect things too, like different peripherals. So it's pretty convenient in that way.
Yeah.
Yeah, it's a really nice board. It really is. And I got the PCIe card. So I've got 2 PCIe cards. I've got 3 Rock Pro 64s. One of them was given to me by the Pine 64 company. So thanks a lot for that. That was really helpful. So I've got 3 of the Rock Pro 4 gigabyte versions, and I've got 2 PCI cards. That's what I'm running the OS on and doing all the building on. Yeah, it's a very nice machine. I'm really pleased with it.
The questions I have is impatience towards what you're doing. And I know it's a lot of work. I know it's a lot of time and effort, but at the end of the day, it's going to be right. So it's just waiting for the time when everything's built and working, and then rock and roll.
Right, so what you're going to see now on the screen, so this is one of my Rock Pro 64s booting. So you can see that it's got, I can't stop it because it's in U-boot, but you can see there that this is booting a version of U-boot that's been self-compiled. And I've branded it Slackware ARM so that when people need help with it, I can see which U-boot they're actually booting. One of the things that I've noticed is that, and I see that Debian also have observed this, is that depending on which U-boot you have in the flash, depends on whether the board boots a U-boot off of an SD card or not. So for example, my primary build machine is still running I think it's from Armbian, it's just whatever's in the flash from the factory. And that boots that version of U-boot off of flash, which finds my kernel initrd off of the SD card and boots it, which is perfectly fine because in the Slackware AArch64 port, I'm really trying to keep it out of U-boot, because one of the things, initially I thought to myself, I'll just do what I've done in ARM because it's just easier that way, isn't it? I've got a known method of these particular commands and I can just change the addresses and that will be good days. But because of the work to get the system bootstrapped, I've gone down some different paths with the booting process, some of which have worked and some have not. And as I've been exploring all of that, I realized that not only my life, but many other people's lives is going to be a lot easier if I keep entirely out of using the U-boot console to have to sit there and actually paste these commands in. As I said before in other podcasts, I could actually automate it. There are ways of doing that with TFTP booting in U-boot, but I just don't really fancy it because it's just more work. And the thing is, to me, I'm not interested in the bootloader. I mean, U-boot's great, but it's not my thing. You know, it's a bootloader to get the operating system that I'm interested in working. So I want to sort of do the bare minimum as for myself and also for the users. If I can keep out of the user having to use U-boot and paste things in, it means there's less chance of them pasting it in incorrectly. And it means I don't have to document as much either. And there's also something else that I found as part of the bootstrap process. Oh, you're going to love this, Phil. I've decided we're keeping the mini roots because I've actually used it to bootstrap AArch64.
Nice.
Never used them before. I was going to use them to bootstrap another ARM platform, but then the kernel became generic, so I never needed to. But I used it to bootstrap AArch64. So not only that, I fixed them because I tried to boot it. There were a number of packages absent from the mini root, which were critical dependencies, so the system wouldn't boot properly. So I fixed all of that, got the mini root to build a bootable minimal Slackware platform. And the best part, well, here's the thing, I had to slim it down a little bit because what I did was I had a problem with USB, which is one of the things that Brent and I have been looking at. And it turned out that my KVM seems to be upsetting the Rock Pro 64. Even in U-boot, it comes up with some error. It doesn't affect any of the other Linux boxes, whether they're ARM or my Lenovo laptop. It doesn't affect anything. Even my Mac is perfectly fine with that. But no, the Rock Pro 64 is upsetting it on the USB bus. So I didn't realize. So I was trying to get the system booting with a hard disk and a USB caddy, and it was coming up with disk errors all the time. And I was thinking, okay, one bad disk. Okay, these have been in x86s, because my ARM hardware is just all old hand-me-down stuff. And I thought, okay, it's probably a disk error. Fine, get another one. Disk error. I'm like, really? Okay, got another one. Disk error. Okay, there's a bit of a pattern, isn't there? And so I realized that I happened to disconnect the KVM from it, and all the errors stopped. All the disk errors stopped. And I thought, oh, okay. But the good thing is that because of that problem, what I ended up with was a pared down mini root running from entirely RAM. So I had basically a Slackware Live running in RAM from that sort of failed experiment and that really odd goings on with the KVM. I've actually come up with this way of simply making a Slackware Live disk image. So what I plan to do, I'm going to provide two SD card images. The first will be to boot the operating system. So you'll put it in and it'll have on it the kernel and the initial RAM disk. It's going to have a generic initial RAM disk. I'll talk about that in a minute. Also on that SD card will be the Slackware installer. So you'll get one SD card image, DD it to your SD card, put it in the machine, and U-boot will offer you a menu using the ext Linux. It's basically like syslinux inside of U-boot. Got a little menu in there, and you can pick whether you want to boot the OS or boot the installer. These SD card images will be rebuilt every time there's a new kernel, so they'll always be in line with the current kernel. So that'll be one SD card image that will contain the installer and the generic initial RAM disk and kernel for the operating system. The second SD card image will be for a Slackware AArch64 Live as well. So you'll be able to try out Slackware AArch64 without having to install it. And that will be essentially the mini root, but pared down a little bit, like removal of the documentation and some other unnecessary stuff for runtime. So that's kind of the plan.
So the initial RAM disk is still going to exist, but it's just going to be on an SD card image. Is it still going to be downloadable as an independent file?
I said that there's going to be a generic kernel and a generic initial RAM disk. So there's going to be a generic kernel anyway, because all of the kernels are generic. And they have been even in the ARM world, ARM 32-bit world for a while. So the kernel's generic anyhow. What I mean by a generic initrd, in fact, this here is the initial RAM disk for Slackware AArch64. As you can see on the screen, there's an error. It can't find init. That's simply because there's no storage attached to this particular board right now, because I'm installing the operating system onto a disk, which I plan to put it on later. I was actually hoping to have had the installation finished by now, but it didn't. That's why it can't boot. But what this is the initial RAM disk. So as I said, because I couldn't get the operating system to boot properly off of the storage because of the USB problem, I ended up booting the mini root in RAM. And that made me realize that I can have massive RAM disks, you see, because I haven't really thought about that for a while. Because ordinarily, when you build the initrd, I've always been concerned about the lack of RAM on ARM. And so I always try to restrict myself. But because I created an enormous brute file system and booted it in RAM, I realized, oh, why don't I just make it a lot easier from the outset for people to be able to take the kernel and initrd that I build and make simple changes to get it to work for, make it essentially more easy to enable lighting up Slackware ARM on other boards. Because in most of the cases, it's going to be a case of changing which modules are loaded during the boot sequence. So in this case, what I mean by generic initial RAM disk is that there's basically, I'm going to include most of the major subsystems that you find in the kernel and more modules to support various different devices. So, more network support, things like that. I'm basically going to try and cram as much as I can into the initial RAM disk. Whilst it does make the initrd larger, well, on disk, it's only about 90 megabytes compressed. So it's not absolutely huge. And the kernel modules inside, I think they should be. I think they are compressed. Yeah, so I've compressed all of the kernel modules with XZ, so that reduces the size down considerably. But this way, even though it's a larger initrd, first of all, it doesn't really matter because, we're not exactly short on storage these days. The SD cards you can buy on the market, I think, are about a minimum of 1 gig anyway. So that's far more storage than we need to store this stuff. So I thought, instead of crippling myself and other people, why don't I just make things a bit fatter because it makes it easier for everyone. That's the direction I've decided to go, which wasn't planned at all, but it just happened that way as I bootstrapped the system. So that's what I mean by generic initial RAM disk. I'll answer your question in a moment, Phil. And so this file here is the load kernel modules file that's inside of the initial RAM disk. This is the standard initial RAM disk that you see on x86, apart from obviously it's built for ARM. What I'm planning on doing here is this file here, this script, is a shell script called load kernel modules. And this script, as the name implies, is what loads the kernel modules into RAM. The kernel modules that it loads into RAM are the ones that you need to provide support in order to access the storage upon which your operating system resides. So, for example, you need the major storage systems, like in my case, USB. I need the PCI drive for the Rock Pro PCI card. Other sort of major platform drivers that you need, and file systems, of course, like X4 and that kind of thing. Load kernel modules script loads the kernel modules that provide support for the platform and the peripherals that you're going to be using. You can mount the storage and pivot root into it and boot operating system proper. The way that this is constructed in the kernel Slack build script for Slackware ARM is that we use the mk-initrd tool that's in Slackware, and you provide it with a list of module names that you want to include in your initial RAM disk. And that makes sense because the mk-initrd script, it runs on the host system, the system that you're running the tool on. And it figures out what it thinks are the kernel modules you need in order to reboot that system. If you create one on your x86, it'll be different from the one that Brent creates, and so on, Phil, right? So what I've done on ARM is, because I use initrd to create an initial RAM disk, and I've done that for many years, is that I supply a whole bunch of modules that are, for example, on the Orange Pi, when you boot it, and I noticed this in one of the previous podcasts when I was editing it, is that you see on the screen that there's various errors as you boot up saying that there's no Marvel real-time clock. Well, yeah, that's because it's an Orange Pi. It doesn't have one of those. But the kernel module script loads the module anyway, and the module happens to spit an error on the screen. I want to also avoid that kind of thing because it looks messy and it's unnecessary. And the kernel.slackbuild script, it's getting quite hairy now. I added in the support for AArch64 and I was like, this is just not going well. I'll finish it, but this is not how I want this to be anymore. So what I plan on doing is changing this script here to look at what the system is at runtime and load the appropriate modules. So it'll have a base platform of modules, various different support like file systems, NFS, well, probably not NFS, although maybe, because some people might want to boot off of NFS. Right, so it's a possibility. I mean, you could certainly do that. It'll load the generic platform modules. And then, for example, on the Rock Pro 64, then it will load this Rock chip host and some other Rock chip 64 particular modules, but it won't load those on other systems, for example. So that will make the boot sequence look a bit tidier. And also I think that it will make it a lot easier to add in other systems. And this script here, this load kernel modules, all of this stuff will end up in the kernel source directory. So I'll be able to edit them directly in there and they'll be packed into the initrd when it's recreated. That's my plan there. And I think that's a good idea. I haven't done it yet, but I plan on doing it soon. To answer your question, Phil, the other bit of it, whilst the SD card images will contain the installer, all of the stuff will still be how it is in Slackware ARM. The initrds will also be present where they used to be in the kernels directory and I think the ISO Linux. So yes, they'll still be available independently of the images, yeah. The reason for that is straightforward, is that the SD card images there's going to have to be one SD card image per device. So there'll be one for the Rock Pro 64, there'll be another for the Pinebook Pro and so on and so forth. In order for the people to put Slackware ARM on devices I haven't yet supported, they would need to be able to access the kernel and all of the other parts, the components, and put it together themselves. Now I can drink my tea.
I'm curious, now that you're doing that with the RAM disks, what was missing exactly that was keeping it from booting? That's the main thing I was wondering about, because I think it was just like one thing. But I'm looking at your list right there. Like, what's your mod probing?
Oh, this isn't booting because there's no actual storage on it. So the system here.
No. I mean, like when I was trying to get HDMI working, that's what I meant.
HDMI works on this one. So this is a fresh U-boot build, and I can. Oh, sorry, no, it doesn't. No. Oh, I see. Right, that module. Right.
Yes.
So what I tried to do with the kernel, I took the ARMv7 config, and I thought, I'll just change the type to ARMv8 and just do a make old config and see what happens. That didn't work out so well. The kernel panicked quite early on. I tried to change it up and I thought, this isn't working. Let's just go back to a default ARMv8 generic config and then just take it from there. When I looked at that, I didn't think about HDMI because I was only working over the serial port. The kernel here, I haven't recompiled with any modules in it. Did I have the module? Is it actually compiled? Did you know?
File.
I don't know what it was called.
I have it working on my system, and I sent you in the email the list that I added to the kernel Slack build. It was just like a very small amount of kernel modules that I added into the initial RAM disk.
Oh, I see. DWHDMI. I got it, yeah.
Yeah, there was something like that. I don't know which one was missing because I think your RAM disk was different by the time I figured it out. The weird thing is in memory it's -HDMI and it has an underscore and as a file. DW_HDMI.
Oh, no, it's not present.
Yeah.
No, that's fine. But this is the initial RAM disk anyway. But what I'll have to do for that, though, is I'll compile that into the kernel because If there is a problem, say booting the initial RAM disk, they won't be able to see it. And if most of the time, I prefer to have them as modules, completely in the dark. If you look, so I think in it's compiling those types of things into the kernel. Where does it load the kernel? Other things, not so much, but things that give you visibility.
Yeah, I was trying to make as minimal changes as possible so that you wouldn't have to.
That's actually where I figured it out when I saw the load kernel module thing with all the mod groups in it.
I was like,
But yeah, I
gotta
understand
find
what
what
a
a
RAM
build
disk.
then.
Well, otherwise, you see,
Looking there.
if you think about it, you wouldn't see anything. I would want the user to be able to see what's going on with UDEV, because that's the only thing. All of the code that's above here, you wouldn't see any output from anyway. The only thing you would is UDEV.
Yeah, it's after you load
Yeah.
like the kernel code.
Yeah, which wouldn't be a problem if if UDEV doesn't break, it wouldn't be a problem because I think you'd see what was on the screen as soon as the module loaded. I'm not sure about that actually, but no, I'll compile it into the kernel. It's just safer that way.
Yeah,
Okay.
I can try it out too. I'll see if I can find something later. But yeah, I just used your generic config that you sent me because I didn't want to have to make it too complicated to fix it.
Cool. Yeah, I'll change the. I need to recompile the kernel anyway. It's I've got an older version on here, so I'm just pretty much waiting to do. Well, a couple of things. So this is the Rock Pro 64 that I'm just installing the latest packages onto to build it. So this one's going to be called Dastardly, and the other one's called Muttley, which is an old cartoon which I used to like as a kid, Dastardly and Muttley. So these two machines are called Dastardly and Muttley, and the other one, I'm not sure what the other one's going to be called. But this one is going to be, I'm installing this now so I can play around with the kernel whilst Muttley carries on building the world over and over. And then I should be able to get the kernel packages finished pretty soon. But I was also looking at whether I could do something with ARM, the way that the kernel modules are loaded as well. But then I thought it's kind of not really worth it. I don't think.
No.
Plus, also, no, I don't think it is because also in AArch64, I'm going to have to basically make the initrd script a dummy, which outputs doesn't work anymore, and explains where to look, because yeah, I need to have a think about that. Can I actually show you the kernel Slack build? So this is Muttley, the Slackware AArch64 build machine, the primary one right now. So we've got, as you can see, it's got its 6 processors. It does start counting at 0, yeah. Okay, so yeah, you can see it's got 6 cores, and it is pretty fast.
Yeah, I noticed that and now I'm like getting used to it, and I'm like, man, this Raspberry Pi is so slow.
Oh, really?
Yeah, it's noticeable difference when I get on the two systems.
Yeah, it's nice, particularly I guess because it's also running off of a PCI card. I haven't actually done a disk speed test, but it should be pretty good. So, oh yes, so the machine has actually finished doing one of the world rebuilds. Unfortunately, though, many of the packages failed. Basically, I've got the system running in continuous integration mode, which means that it takes all of the packages in the ARM tree and puts them into a list and just processes them all and builds them all. What that means is, though, is that when there's some major version change going on in Slackware, it may build that package and then it installs it. Then other packages that, depending on that previous version of the shared object, don't work anymore because it's been removed from the operating system. So as it starts building, it starts leaving a bit of a trail of destruction. So that is one of the things I was thinking, what's going on? These build scripts work fine. I was thinking, I even had those packages built. And I was like, oh yes, because we've had some major library changes in Slackware going on. Although fortunately, I've been planning how to deal with that. So I think what I'll do is that once I just have a break from building Slackware for a bit, I'll leave the tree alone, and the AArch64 port over probably the course of a week will rebuild itself back to a completely stable and fully linked operating system. Because I've built it a couple of times already off of a snapshot, so it wasn't changing, which is deliberately because of this reason. So I'm not sure exactly how many of these packages are going to work on Dastardly that's currently installing at the moment. But I guess we'll find out, won't we? But
yeah, boot it up, broken.
so let's build Bash, just see how long that takes. Oh, that's a thought, actually.
It's just the base system, right? That you're
What
going to
is?
build. Well, what you have built so far is the base system, but you're trying to add on everything else.
Oh, no, I built everything apart
Oh,
from
nice.
KDE. I built every package. It's just that
Oh
many
my
of them
God.
have failed now because of the things, some of the major
Yeah.
libraries have changed, so the packages are failing around it. But the thing is, it doesn't matter because the base system, that was the first thing I built. And then my R2B tool has gone through building everything already. So I already had, not everything, but probably 95% of the packages apart from KDE. So I've got basically a full system on here now. And
Nice.
once I leave the R2B tool running, it will eventually rebuild everything again and it will work. This feels like it takes longer now that we're looking at it. Okay, so the configuration always takes a bit longer, but the building of it, this is pretty fast.
Yeah.
Although I
It's
have
building the configuration locally.
exactly. So this is running off, I think the num jobs is slightly incorrect on this one.
I had to tweak that a little bit to get it to work. It was missing a J.
Oh,
Because I don't have more than 6 something or others. I forget what the script said. There's like an if statement that talks about the num jobs in the dbuild script.
Oh, I don't know. That's really old now. I've
Yeah,
changed.
I figured. Yeah.
Yeah, I've changed that quite significantly now from the one that's on the FTP site.
Cool.
So that didn't. Oh, I didn't time it, of course. So that didn't take particularly long. But this is using distcc over to a couple of x86-64 machines with the cross compiler on them. But it's also building locally as well on the 6 cores. So it's pretty fast. If we run that on ARM, it's a heck of a lot slower. Yeah, it's interesting as well. While I was doing the world rebuild, doing some experiments on what were the most efficient number of parallel makes you could build, or parallel jobs you could have running on ARM, and it turned out that it's basically just the same as the number of cores that you have on the system. So now, because I was thinking to myself, how am I going to make it so that I can get distcc to select the correct cross compiler, depending on which architecture is calling it. So I was thinking about how to do that. And then once I'd done some tests on ARM, I realized that because one of the issues is that with certain packages like which one was it? So I think certain packages like Qt, they can end up doubling the number of parallel jobs. So if you do -J4, it'll run 4 jobs in parallel, but one of those jobs may fork another job, which also runs -J4. And so I found the ARM systems were struggling. They were sitting in swap for a considerable amount of time. It's one of the good things I've realised of because I've been spending a lot of time working on the build system for AArch64. Is I've been looking into these things more extensively than I had before. So I've been tweaking the number of parallel jobs for ARM, and it turns out that just having it equal to the number of cores works pretty well, and distributing that over distcc.
Yeah. That's what I ended up doing too. It was kind of confusing at first, but I kind of like figured out how your script works and then I had to modify it so it would work on it. But
Yeah.
because it doesn't have the AArch64 case statement at the top, and there's a few other things like that that make it not work.
What was that?
Debuild, I meant to say. Yeah, debuild.
Oh.
Yeah.
Yeah, I suppose I should put out a new version of that at some point. I can't remember what's in it at the moment.
There's no rush. I mean,
Yeah,
it works.
I'll get around to it, I think.
But, like you were saying about the swap, when there's too many cores being used, that's why I started using ZRAM. It literally, changed how quickly things built. Instead of going to swap, it just went to RAM quicker because it changed the swappiness. And it wrote background processes to disk quicker and stuff like that. So it was easier to build things on just one machine.
How does it work?
It's kind of like having like a mounted hard drive, but it's in memory, so a block device, and it uses it like a swap. And if you have, like on the Rock Pro, you have 6 cores, so you make a swap for every core so that it can multitask better, and you try and just kind of have it add up to the total amount of memory you want to swap with. I don't know how to explain it exactly very well, but that's why I wrote the Slack doc, because I figured I could explain it easier that way.
Okay. I'll have to have a look at
Yeah.
it, because I saw you posted about it to Linux Questions, but I hadn't looked into what it was.
Yeah. I need to change like stuff to explain it a little bit better, but how to set it up is all on there. And I need to write a better RC script. I just have it in RC local.
On this initial RAM disk here, my kind of question is, I'm wondering whether anyone would miss the mk-initrd tool, because I wonder if anyone actually modifies their initial RAM disk from what it was. So even on ARM, for example, if you run it, this is one of the other issues, is with the mk-initrd on ARM, it's never worked properly. It doesn't detect everything that you need in order to boot the system again. So in the documentation for it, I point to the users to look at the kernel Slack build script, because that's where the authoritative list of modules are that you need for a particular platform, or rather for the platforms that I support. So basically, if I make this essentially non-self-serviceable, in a sense that when the initrd is packed up, so I'll show you what I'm actually talking about, seeing as we can. So when this initrd is packed up, there's no sort of Slackware tool to unpack it and work with it. Does it really matter? Anyone can unpack it with CPIO, because that's what it is, and you can easily repack it. So it's easy enough to do with the Unix toolset that's already available. But does it really matter that there's no actual tool to manage it? I suppose I don't think it matters. Do you know what I'm talking about, by the way?
Wait, say that again.
So this is the boot directory of Muttley, one of the Slackware AArch64 machines. And this setup is the same on ARM as well. So this is the initrd here. What I'm planning on doing, this section here, as you can see, is a whole pile of is setting various variables to contain module names. That's all it is.
Yeah.
In a categorized fashion. So I start off with generic stuff that's applicable on all systems, regardless of whether it's ARM or AArch64. And then we work our way down AArch64, which is called ARM. Well, I'm calling it ARM v8 in the kernel, because I called it ARM v7 for 32-bit. So that's what I've copied the same thing there. And then for ARM v7 or ARM v8, we go another depth and add in some specific modules that we require there as well. But as I was doing this, I was just thinking, this is crazy, and this is getting out of hand now. So what I plan on doing instead is, as we saw earlier, that load kernel module script in the initrd, I plan on changing that to just be a different shell script that loads modules at runtime, rather than doing what we're doing here, which is, as you can see here on the screen, is this is you running this mk-initrd tool, and it's supplying it with, here's this big list of modules that I want you to add to the kernel, and it'll take those modules and also find out any of its dependencies and package them up into the initrd. It does a good job of that, but if I don't specify all of the modules, it will not create an initrd that works properly. So it's never fully worked on ARM as it should do anyway. It does work on x86 perfectly fine. What I'm saying is that instead of using this tool here, this mk-initrd tool, it unpacks this archive, which is part of the Slackware package for mk-initrd, and it changes some parameters inside of the initrd. It packs it up into an init ramfs, and then we gzip it. So that's basically what it does. So my plan is to use the same initrd tree as we have in here, but load in all of the kernel modules from the kernel.slack build, and then have the load kernel module script, a shell script that controls which modules get loaded at runtime, rather than just telling it to go and load the whole kitchen sink and the house, and put up a tent as well in the back garden. So we're trying to be a bit more discerning about what gets loaded at boot time. The question is, would anybody miss the mk-initrd tool? Because I don't want to supply it and people think that that's what you need to use in Slackware AArch64 and then end up creating their own initial RAM disk, which doesn't work properly. So for example, if you type this, it will just say this doesn't function in Slackware AArch64. But I wouldn't be providing any tools to change the initrd here that I've highlighted. They would basically just be set. But you could go in and edit it yourself. It's not difficult.
Yeah, just 2 commands.
Yeah, exactly. You just do zcat initrd like that. I do so much recently. There's I had a little brain fart. I couldn't remember the thing. Yeah, so
I have all these like text files with notes now because I'm like forgetting stuff that I did.
Yeah, I know it does get to a point when there's so many details of this command line switches. There's only so much you can remember. Yeah, so basically that's it, and then you could just easily repack it. So it's not particularly difficult. So I don't know if anyone's got any ideas. Let me know. But that's the way I'm thinking of doing it. Is just having that creator. It's not going to be self-service, but I don't think it matters anyway. But for people who want to put Slackware AArch64 on new machines, it's going to be easy enough to work with it. So that's the plan.
Yeah. Or they can run the kernel Slack build and it'll generate it all. Isn't that the idea?
No, you don't.
Oh, okay.
The kernel Slack build's not really it's not really user facing. I mean, for ARM, when you look at that document, which is .initrd, this document here, it's similar to the original one in x86, but on ARM, I've said that it references the kernel.slack build.
Yeah. Oh, okay.
Oh, sorry, I've made a mistake. It's the MK. Okay, mk-initrd is the tool that assembles the initial RAM disk. This is a script I meant that doesn't work, has never worked properly on ARM. Is the command generator that's the tool that figures out which modules are required. So yeah, but that's, as I said in here, it's never worked properly. So then I tell the users to go and have a look at the kernel Slack build, but that's only to find out what modules they should reincorporate into their new initrd. But I've never heard of anyone actually using it. But then again, I also don't expect anyone to email me and say, "Hey, I've recreated my RAM disk either."
Yeah.
Oh, good for you, dude. Glad you're having a good time. So yeah, please don't email me. I'm not interested too much.
I was just tired of like changing one thing and then not working, so I had to go do something. So I just ran it, came back, and then used it. So.
Oh right, okay. Yeah, so I think also that doing it this way is going to make it a lot easier anyway. And having a larger generic initrd means that you won't need to do this stuff anyway. Really, you'll just have to change most of the modules will be included, and all you really need to do is just load them.
Yeah, it wasn't like when I included at one point I just put all the modules in and let them load with modprobe, like with load kernel modules, that script, and it booted up just fine. I'm like, oh, so it works. But it wasn't like that much overhead. So.
No, not at all. No, it's not. I mean, so that Muttley is running off of the same image that I gave you, an older one. But it's I haven't changed the load kernel modules for ages. I haven't been working on the kernel recently. Yeah. So it's the same one. Yeah, it boots perfectly fine. And that's what it's running from. You just reminded me about something, which was you asked whether I'd be expecting users to run the kernel Slack build, and no, I wouldn't. But that reminded me, I did think about where to put those files. So for example, I was thinking maybe when we were working on the ARM trusted firmware stuff, I was thinking to myself, maybe I should just make an ARM platform package and bundle the firmware and bundle the U-boot binary stuff into that. And then also bundle the load kernel module script as well, so that it's easier for the users to find.
Yeah.
And then the way I was going to do it was to have, just have the shell script probe for different files and just assemble them or just source them from the shell script inside of the initrd. So it makes it, I haven't quite fully figured out what I'm going to do with that yet. Exactly.
Yeah, that sounds like a good idea, but I mean, I guess it's just a matter of knowing like what exact modules you need, you know. That's the issue. Like if you start porting to new systems, new boards.
Well, here's the thing, right? So that's a really good question. So normally the way I do that is booting the Slackware installer. So usually I get, because on ARM I've already got the whole system working. So yes, I've already got an installer. Let's just boot it and see what happens. And then because inside the installer I package quite a lot of modules inside of it, and that's one of the reasons why is I can just mod probe them and see what happens, and then figure out the list from there. So that's normally how I do it. But on AArch64 I couldn't because I hadn't got the installer working yet when I was doing this. I still haven't actually at the moment, but I haven't really tried either. I've made the changes to get it to do what I want it to do, but I haven't tested it yet. I'm waiting for the world rebuild to finish. But what I would do there though is use the Slackware Live, the Slackware AArch64 Live, and then because that runs in RAM. I would imagine, given that I didn't really do anything clever to get it booting on a Rock Pro 64, I just ran the generic ARM v8 kernel, right, with the modules and just bundled all the modules into it and booted it, and it worked fine, right? And that's a generic kernel. I was booting it off of the, I was controlling it from the serial port, but if you're going to be lighting up a new platform, then you should have all of those types of things anyway. So I think that will help figure out which modules are required pretty easily. That's my plan anyway. But I haven't. Yeah, I've been thinking quite a lot about what to package and where to put it, because I thought maybe I should have an ARM packet, an ARM platform package, put the trusted firmware in there, put this kernel config stuff in there, maybe even move the U-boot tools into there and V-boot tools as well, and sort of have a monolithic package. But then I thought, why is anyone going to want the ARM trusted firmware in a package? At the end of the day, it's only me that builds it anyway, and I can leave it where it is in the board support directory on the FTP side. It's not part, it's not a Slackware package, but it doesn't matter. You can find it quite easily.
Yeah, my script, like the build script I sent you, it was just because I wasn't sure what you needed it for, so I just kind of, put it together. A lot of it's just generic commands from a Slack build script, so.
Yeah.
Yeah.
Well, no, that's what I was wondering. I thought, because I saw that some of the other distributions were packaging it, as a package, but then that doesn't kind of really make any sense. Because
no, I think it's because they're using it on build machines so that they can include it into stuff. So.
Yeah, that's true. Yeah, that's true. I don't work. It doesn't mind doesn't work like that. Oh, plus the fact, of course, we can't compile ARM trusted firmware natively anyway.
I know.
So, yeah. So
I'll have to look into that more. Maybe there's something I can do. I saw a patch. I saw a patch that builds it on CLang. So.
Well, when I looked at the make file, if you try to build the ARM trusted firmware natively, it gets a certain way, and then it tries to compile it for software floating point. Some other 32-bit compiler flags that not even my 32-bit ARM compiler has.
Yeah.
Although it does work perfectly well when you cross-compile it with the same version of GCC. So I looked at it and I just thought, what? And then you came back with this nice workaround to use the cross compiler, and it works perfectly fine on x86-64.
So the reason why that I figured that out is because I build cross compilers for ARM and ARM64 on all my ARM devices, because I just run the X tool chain, whatever. And I noticed it wasn't building on the Rock Pro, but then it was building for a second on my Raspberry Pi, and then it started building again on the Rock Pro over distcc, I mean. So I was like, I'll just try this on my laptop and get it working that way.
Oh, I see. Yeah, because you said it had worked, and then I thought, hold on, no, that you must be doing it over distcc, and that's why it's working for you.
Yeah, and that's why I included the distcc part to it.
Yeah. But I didn't even realize you were doing that. I just ran it. I ran the script on my x86, which has the cross compiler in exactly this place, has both of them on there, and it just worked beautifully. And I got the binary built within about 3 seconds flat.
Yeah.
So that was nice.
Yeah.
I think.
Well, and what I ended up doing was pointing my distcc clients allow and my hosts to localhost, and then it would just find the compiler.
Oh, right. Okay.
And you you make cc equals distcc, and then you run, num jobs and all that.
Right. Okay.
do see this script, the SOCs variable, you can just add RPI3 and RPI4, and it will build those too. So.
Okay, all right. I did see, Brent, that was in there, and I did laugh.
Yeah. No, I left it in there by accident. It was an accident. But
all right.
I just took it out of the RPM. It's like, oh, that works. Okay, I'll just leave it.
This is outside of the done loop. There we go. That's why. I'm pretty certain that's it.
Yeah.
Yeah, because the
That's
sock,
how I had it wrapped.
Yeah, I was going to say, that doesn't make any sense at all. I mean, obviously, we're just doing this for the show. Whenever we do anything, it works first time, every single time.
Yeah. We put it in there.
There we go. We've got some trusted ARM firmware for the Raspberry 3 and Raspberry Pi.
You can trust your Pis now.
Yeah, so that's that done. God, my machine is still, dastardly still installing. That's going to take a while. So, yeah. Yeah, so I'm going to put this machine back into the continuous integration mode and let it go. So then what's going to happen is it walks the Slackware ARM tree for each package, does a bit of sanity checking on it, and constructs a build list. And then it gives the build list to the R2B tool, which builds it once. And then the tool runs again and reconstructs the list. So any packages that get added will be picked up. I haven't made it deal with any packages that get removed yet, although I have thought about how I could handle that. But then I thought, oh, maybe in the future I'll deal with that problem. For the moment, I'll just be happy that it's building and I don't have to touch it too much. When I did all of the work to do the update for the 64-bit support, I thought I'd scripted pretty much all of it. And then there were lots of things that were still not quite right. There were a few parts where my scripts hadn't picked up, where there was some non-standard variable names or something like that. I actually built this tool. I don't know if it's...
You have a little message of the day that tells you what it's for.
Yeah, just in case I didn't know. Yeah, so I wrote a tool called R2B fails, so it could walk through all of the build failures. And so I would see that, and I'd see that there's quite a lot of packages in Slackware. There's about at least 80, I think, where the version of libtool that's bundled in the source is so old that it doesn't know about AArch64 yet. So then I added a little function to the SlackKit package to find where these config.guess and config.sub files are and replace them with the latest versions from libtool. There's a lot of grunt work involved in just changing scripts and things like that.
There's a lot of stuff that's changed, I'm sure. I mean, like, I've even seen some ARM stuff make it into Slackware current, 64 current, in the Arch checking for the architecture. So, like, if you look at bin utils.
Is there? There shouldn't be. I don't recall seeing anything in there. I mean, I made some changes to Slack package. That was one of the first things that I did to add AArch64 support into that, because Robbie Workman was working on it at the time on IRC. So I was like, oh, I'll just hack it now, and there you go, done. Can you commit that for me, please? And he did. Thanks for that.
Oh yeah, all it does is check for ARMv7 and ARM star.
One of the things I was thinking about was asking Pat whether it could enable ARM support inside the bin utils in Slackware x86-64, because what you can't do is it, for example, on here, dev select this. So this is the installation I want to put on Dastardly. So this is the hard disk I'm going to connect to Dastardly. I've got a 2.5-inch drive here, a SATA drive, that I'm going to connect to Dastardly, but it's currently connected to this little laptop. And I've NFS mounted it onto Mutley. I can natively install the package to the target storage.
Yeah.
And I'm hoping that I can root into it and it works. Oh yeah, there we go. There we go. So that works. The other thing I need to do, because even though I've got some modules in here, they are okay. Okay. So even though I've got some modules in there, they are quite old ones from my kernel, because I haven't rebuilt the kernel package for a long time. So the kernel I gave you, Brent, was one that I just built out of in/tmp and just compiled it, because it's easier,
Yeah,
obviously,
it's just a test.
Exactly. So I don't have the kernel package that got installed that put the modules there was not the right one. There's quite a different bunch of modules, I think. So I'm just going to copy the kernel modules off of Mutley, the running system. Oh, do you know what I did as well? So this machine, Dev32, which is this one here, I accidentally put the ARM modules onto this 32-bit x86 machine. So basically, and I thought, oh, so this machine's not going to reboot, is it? I might have to reinstall the machine. Oh, you know, the other thing I did when I was doing the AArch64 port, because I was doing it in some spare time. I see something, go and fix it, and then leave it to do its thing. And I was doing something quickly, and I installed accidentally. So I found out that the -- root option to install package does not exist in Slackware 14.2's package tools.
You can set the variable root, capital root equals, and that works, I think.
That's
unless
right.
I'm not remembering.
No, you're right. That does work. Only my script didn't do that, and I ran it on an x86 machine, and it got as far as installing AAA glibc solibs of AArch64 libraries onto my x86, and it's quite funny because it installs, and then within a moment you've basically pressed return. And it's like installing, boom, system blown away. It's all good fun, causing your operating system to come to an abrupt halt. Install some AArch64 libraries on it. Yeah, it's a complete accident. And I was thinking, how has that possibly happened? I was looking at the screen going, huh? How could it? This doesn't make any sense. How could it possibly be that it's hosed the x86 system? I've run this script loads of times. And then I realized I'd run it on a 14.2 machine, whereas previously I was running it on a current machine with a newer version of package tools. And unfortunately, package tools doesn't detect if you give it an option that it doesn't recognize. It just carries on anyway, but doesn't, of course, set the root variable. So that's what happened there. So I've done I've had a few missteps as I've been doing this and had to go and rescue the system. Fortunately, it's pretty easy. You just boot into the Slackware installer off a USB and then just put the x86 package back on it and run ldconfig. You don't even have to do that. You just put the package back on it and you reinstall the package a couple of times. Do you know what I have noticed, though? Something interesting while I've been doing the installation is that installing the glibc package onto a target that's NFS mounted causes the post-installation of glibc to fail with the flock saying that it has a timeout. So my glibc package didn't get installed properly. I had to go and reinstall it manually inside of here. It doesn't happen on the local file system, but for some reason it does when you're installing it onto an NFS target. Or at least it does on here. I haven't tried it on ARM or x86, but I found that interesting and unexpected.
Because I haven't actually. It's just when it's installed with like package tools, or when it's, I don't know.
Like this. So for example, if you do, even if it accidentally installed it onto the root file system, it wouldn't matter because it's the correct version anyway. It's already on there. So it wouldn't break it. Yeah, so it gets into this point, and that's where it just hangs. And the script takes a moment to install anyway, but it'll say that it's getting stuck on flock. I wonder why. I guess it's to do with NFS. I've never done an NFS installation like that before, where the target is on NFS. I've installed off of an NFS export. I do that all the time. Yeah. I'm curious whether it works on x86, actually.
Yeah, I've never done that either.
No, you'll see in a minute when it fails.
So you just mounted it locally and then try to install on it, and that's what happens?
Exactly, yeah. So there you go.
Yeah.
Yeah. So yeah, this target is NFS mounted. So I'm installing the package onto somewhere that's NFS, onto an NFS export.
That's unfortunate. That would have been a cool thing to have.
Yeah, well, the thing is, I've never tried it before. It's just that I was actually going to plug the hard disk onto the Rock Pro 64. I was just going to put it into a USB caddy, and then I thought, oh, hold on, I don't want to plug anything into the Rock Pro 64 that's building the packages, just in case it unsettles it and causes it to crash or something like that when it's building packages. So I'm kind of, my hands are off the lead machine. I'm just keeping away, trying to leave it alone as much as possible, apart from fiddling with it like this, of course. While we were doing the glibc 2.33 update in Slackware, I had a few issues as well. I actually, when we were doing the update from, what was the previous one, 2.30? I can't remember what it was.
I think it was just 32.
Oh, no, it was 30, it was 30 something before, and then it was 32, and then we went to 33. So yeah. I just didn't do a world rebuild for 32 for ARM.
I think it was originally 2.30, yeah.
Yeah, so when we were doing the first update to 32, I managed to hose the AArch64 machine completely.
Yeah,
it took me a little while to get it booted again. And it was a bit odd. And I found that this object here, the loader, became 0 bytes. And I was just like, it took a while to figure out what it was. And luckily, it wasn't just me. It turned out there was a few other things going on as well that we had to fix up. But yeah, that was fun. But anyway, this one looks good. So just make sure that it still works. Yeah, cool. So what I want to do is unmount that. Of course it's busy. Oh, okay, right. I think it's because it's because it was an NFS export. Because you have to explicitly state that mounted storage is included in the export. So yeah, that's what it was. Right, so I should be able to now just unmount that. Okay, so I've just taken that disk and plugged it into the Rock Pro 64, but it's on a USB to SATA converter. So I've actually got the storage connected to the USB bus because I haven't got a I haven't organized power to power the storage externally yet. So I plan to connect the same disk into the SATA bus once I've sorted the powering out. So it's booting the same initrd as you saw earlier, and it's found the disk and it's loading all of these modules, and it should drop me into a shell. Oh, okay, yeah, fine. So yeah, so that doesn't work because it's actually on SDA2 on this disk. I didn't follow the same partition layout. Yeah. But if we change, oops, I'd have to change the.
Why is it trying to detect RTC DS1307?
Well, as I said earlier, that's one of the problems, is that the load kernel module script is loading a whole bunch of modules for hardware that's never going to be present on particular boards. That's why I'm going to change it to detect at runtime what the platform is, and then load the appropriate modules. So you won't get any of that kind of mess in the boot sequence. What happened to you, Phil? Where did you go?
How long have you guys been talking without realising I wasn't there?
I knew you weren't there because you just weren't responding.
All right. No,
I was singing to you and everything. I even sang Rick Astley, didn't I, Brent? I thought that might wake you up.
I bet you won't include that on the released podcast, man.
No. Right, so what I'm going to do is change the root dev to, it would be SDA2. So let's change that to SDA2. So what I'm changing in here, these files, is these are also in the Slackware x86 initrd, and the MK initrd tool creates these files for you. That's one of the things that it does. And rootfs should just say X4 anyway, I think, yeah. And this is also one of the reasons why it's more complicated on ARM, is that if you unpack the initrd for ARM 32-bit, you'll find that the root dev is whatever it is on the build machine that it got created on. Inside the U-boot console, in the instructions, that's where you need to set the root dev as a kernel parameter so that it overrides what's in this file. So hopefully with the AArch64 stuff, that might get a little bit easier. Yeah, it might do. It should do. Yeah, so what I've done there is I took the SD card out of the Rock Pro 64, put it into the laptop and changed the initrd contents to change the root device and repacked it. So I put the SD card back into the Rock Pro 64 and it's booting now. So I'm guessing, Brent, yours doesn't quite look like that when it boots. The one with your one.
Goes up on my HDMI, but in my console it doesn't. My serial console. It's just garbled. But then it boots anyway, so.
Yeah. That was one of the things. That's quite frustrating actually. But I had the same thing when I've got loads of these adapters. I bought a batch of them off Amazon a while ago, and they're really cheap. But I've had a couple of problems with them on ARM, and I just discarded them, and then the next one was perfectly fine. But on Rock Pro 64, I had loads of trouble as well. But then I saw that that's all over the forums. It seems to be quite common. But I've not had any problems now though. Well, I've got two settings for screen, but as you can see, it works perfectly fine now. So what's happened is now the initrd has opened a shell as well, and that's something I've added in just for development reasons, so I can test the initrd before proceeding. So I'm just going to quit that, and hopefully that should boot into a working Slackware AArch64 operating system. Although I haven't. Well,
it's working.
oh yeah, of course.
No.
Of course. Fortunately, that's fine. So because I haven't got the Slackware installer done yet, my temporary installer is very similar to how the mini root works, and all that's happened is that it's there we go. It's just that the FS tab is wrong, that's all.
Mm-hmm.
Yeah, here we go. So that should be SDA1, and that needs to be SDA2. Okay. I don't know I'm not sure it will reboot actually. Let's just reboot it. Right. So yeah, this is strange, Brent. This U-boot, that looks to me very like one that I compiled, and it's in the SPI flash.
Yeah, I ended up just erasing my SPI flash and then just saving my configuration to it. And I don't have U-boot on it. So it's always booting yours.
Maybe that's what's happened on here, because I honestly don't remember what I did. I was trying to get, you're trying to get lots of different things working, and then you kind of don't want to make so many extensive notes as to exactly what you've done because you think, I probably won't need those. At least that's what I do.
Hindsight, I probably would have left the onboard U-boot alone.
Well, yeah, I'm not a great fan. In fact, I'm not a fan at all, and don't advocate replacing what comes in the factory. I just generally think that's a bad idea. If it goes wrong, someone's taken what you've done on good faith and it's not worked out. If that leaves them with a bricked system in any way, I think that's a really bad user experience. In ARM, it's always been, here's an SD card, pop it in and it'll be just fine, and then take it out.
And we don't want people to have to put a jumper on the SPI flash just to get it fixed either. That would just be counterintuitive.
Exactly, yeah. So I need to look at that. I need to figure out how the whole landscape of the boot on the Rock Pro 64, because it's good though that you've had this issue, and I've had an issue on my other Rock Pro 64, which I still haven't salvaged yet. I need to sort that out actually, but it's good that that's happened, because it gives me an idea that these things do happen to people even without really wanting to, So
yes, and the trick is when you see U-boot load, there's a certain point right after it gets to like 3 seconds into auto load, you can pull out the ground of the SPI flash, and it will work. It'll just work. So it'll use like the default settings, but you can read your SPI flash again, I guess is what I should say.
Oh, okay.
Yeah.
I need to have a look at that. Oh, okay. I'm trying to do an NFS mount, but it's not going to work because I haven't got any network cable plugged into it. But yeah, anyway, I was just about to go and set it up as an AArch64 builder and start playing around with the kernels ready when I've got some time next week. But as you can see, that is a freshly installed AArch64 installation from the latest package sets that have been building as of right now, and it works. It boots. So there's still work to do on the kernel and various other things, but yeah, it's maybe in a couple of months I might be able to push it out. But I've got a lot of other work to do on the 32-bit port at the moment to get that ready for 15.0 release. But I've got to go now, guys. Take care, guys. We'll speak again soon.
All right.
No.
Cheers.